Hey you guys, in this video I'm just going to work through a couple examples of solving some polynomial inequalities just to give you an idea of kind of the steps we take when we go through this. Starting with number 2 up here, essentially what I want to do with number 2 to begin with is take a look at a situation where we would just want to test these x values to see if they're actually solutions to the original polynomial inequality. So one thing I want you to do as you're working with polynomial inequalities, first things first, is to get one of the sides of the inequality equal to 0, and if at all possible, factor the other side. So I noticed that the left side of this, actually I could write this as x minus 4, x plus 3. And we're going to say that this is still greater than or equal to 0, but when we test x values, it's really a convenience to test it into a factored form compared to a 0 on one side, as opposed to the original form compared to a 0. Not that any way is better than the other way. So let's go ahead and check out just how I am going to test to see if an x value is a solution to an inequality here. So we're going to plug this in, but when I plug in my 5, what I'm going to do is I'm going to plug it into the factored form if I can help it. So I get 5 minus 4 and then 5 plus 3 here. And this is still listed as greater than or equal to 0, but what I see is that I get this. I get a positive 1 and I get a positive 8. And that's greater than or equal to 0. So the neat thing about this is a positive times a positive is a positive. Now granted, I do get positive 8, but the bottom line is, since we're comparing this to 0, really all I want to know about the left-hand side was, is it positive or negative? Because if it's positive, then that is true that it is greater than or equal to 0. And if it was negative, I could tell you that no negative number could be greater than or equal to 0. It would be false. So since this is true, we're going to say that this is a solution to the original inequality. Let's take a look at what a non-solution would look like, 0 here. So if I were to plug in 0 into this factor expression, I would get 0 minus 4, and I would get 0 plus 3 greater than or equal to 0. In this case, you can see that I get a negative 4 times a positive 3 is greater than or equal to 0. But the bottom line is, I get negative 12. But the bottom line is, I got a negative, you guys. And if I got a negative is greater than or equal to 0, well, then I would be lying to you. And so this would be a false statement. And it would just go to show that this is not a solution to the original. So first things first, just keep in mind that when we test these x values, we plug them back into the original. And also some things like we like to have a 0 on one side. And if we can at all help it, we'll factor the other side that is non-zero. So let's take a look at some actual inequalities that we need to solve down here. And I suppose that I'd be inclined to look at just like number 10 with you here. So some things. First things first, we are always going to get a 0 on one side first, and then we're going to factor the other side if at all possible. So this thing, I notice, is a difference of squares. It does factor into x plus 4, x minus 4 is greater than or equal to 0. So now that I've got this set here, let's go ahead and take kind of a consideration of what it is that we're actually saying. And so what I've done is I actually went into y equals on my graphing calculator, and I graphed x squared minus 16 equals y. But what we're really saying is that this is some expression here that represents y. Or in other words, we could say f of x equals the left side equals x squared minus 16. So if that's the case, then really what we're trying to answer here is this. What are all the x values that would cause my y values to either be positive or at least 0? So the neat thing is when you look on this graph right here, we can see on this graph of this parabola that was shifted down 16 units and opens upward that it is positive y values above the x-axis right here and right here. So again, recall that the question was, what are all the x values that cause this to be positive or at least equal to 0? And so we can see that it's going to be any x value that is negative 4 to the left or any x value that is positive 4 to the right. When we plug those in, we're going to get positive y values are equal to 0. So really the one thing I do want to point out is essentially this. In order to figure this out without a graph, what I want you to understand is that our graph could only ever go from having positive y values to negative y values if it crosses over to 0. And it could only ever go from negative y values to positive y values if it crosses over to 0. And between two consecutive zeros, like between negative 4 and positive 4 in this graph, all of my y values would either all have to be negative or all positive, but it couldn't be both without crossing another 0. And then outside of my zeros here, so to the right of 4, my graph is all positive y values, but it couldn't go back to being negative y values again unless it crossed over another 0. So once you get a 0 on one side and you factor the other side, if at all possible, what we're going to do is we're going to list our critical values. Now I'll have you know that the critical values are all of the zeros of the original function. So in this case we say the two critical values are plus or minus 4. So What I like to do at this point is I like to set up a number line just to kind of visualize this here. And what we're going to do is just for now, we're going to put on our two critical values. I'm going to say 4, and I'm also going to say -4. So right now, all I know is that these are critical values. But what I want you to understand is what that does is if I have two critical values is it splits our number line up into 3 different intervals from -infinity to -4, from -4 to 4, and from 4 to infinity. Now, because we've seen this graph, and because I know that I'm looking for all the x values that cause my y values to be positive or 0, I already know that in terms of intervals, to the left of -4 and to the right of +4 are going to work. But how would I normally test this? Well, what we do is we set up what we call test intervals. I just want some room here, so I'm going to write off on the side here. So test intervals. And the test intervals we set up around our critical values. So essentially what we're going to see is this. -infinity to -4. I'm going to put a parenthesis for now. Our next test interval is from -4 to 4, and then our last test interval is going to be from 4 to infinity. So here's our job. We know that on these test intervals, my function either has to be all positive y values or all negative y values. So what we're going to do is we're going to choose a representative x value from within each interval to go plug into our original inequality to see if we get a true or false statement. So I always do this. On my outer intervals, I pick an x value that is immediately to the left of our endpoint here. So like -5 would be a good one to plug it in. On the outer interval to the right, I'd plug in +5. And then in between -4 and +4, I'd be crazy if I didn't choose 0 to go test. So what we're going to do is exactly what we did up here on number 2. We're basically just going to go plug these x values in to see if we get true statements or not. So what do I plug them into? Do I plug them into the original inequality or do I plug them into the factored inequality? Well, I'm always going to encourage you to plug it into the factored inequality. So if we're going to test these out here, let's see if I can get myself some space here. Then our original factored inequality here is going to be x plus 4. So I would test -5 plus 4 times -5 minus 4. And I'm checking to see if this is greater than or equal to 0. So in this case, I get a -1 times a -9 is greater than or equal to 0. Bottom line is I care that I got a positive is greater than or equal to 0, which is true. And so if that is true, I'm going to put a big box around this interval. I'm going to say that then everything on that interval should be true. When I test 0 this time, I'm going to get 0 plus 4 times 0 minus 4 is greater than or equal to 0. But in this case, you'll notice that I get a +4 times a -4, which again, since we're comparing it to 0, really all I care about is that I get a negative product on the left. And if you're telling me a negative product is greater than or equal to 0, then I'm going to tell you you're a liar. So this is false. But also what I could say is, well, then no x values on that interval are going to satisfy this original inequality. And then as we test 5 here, I can test this again. We say 5 plus 4, 5 minus 4. I'm just plugging this in for x in my factored inequality here. But what I see is I get a +9, and I get here a +1. So a positive times a positive, last time I checked, is a positive. And so this would be satisfied. This would be a true statement here. And so I'm going to put a box around this interval as well. So with respect to my solutions, let's go ahead and write my solutions here. You'll notice that I said you have to graph your solution set. So our solution set was around these critical values here. We're going to say everything to the left of -4 is what I would graph, and everything to the right of +4 is what I would graph. Now, the last thing we have to confront is this. Should I put brackets or parentheses around negative and +4? And so one thing I want you to recall about this is that these were the zeros of the original function, meaning that if I plug them into the original function, I'm going to get 0. So that being said, if I were to test -4, I just want you to see this. I get -4 plus 4, and then I would get -4 minus 4 greater than or equal to 0. In this case, I would get 0 times -8 is greater than or equal to 0. But the bottom line is I get 0 is greater than or equal to 0. So one thing can be said is that this is true. Another thing that can be said is this. If this is ever greater than or equal to, or less than or equal to, what we're going to commit to doing is we're going to include the zeros as endpoints here. And so my solutions, if I write this in interval notation, is just simply this. All x values, -infinity to -4, bracket, in union with 4 to infinity. So our solutions would be these intervals, and our graph would be what you see right here. Cheers.